All right, today we're going to be solving quadratic equations using the square root method. Now, the big deal here is the only way you can solve one using the square root method is if you have a value squared and a constant equaling y or f of x or 0 or whatever. If there is a value squared, then I can use the square root method. So you can't use this all the time, okay? For example, if I have x minus, or x squared minus 3x, and I have minus 28 equals 0, I'm not going to use the square root method to solve for this. The reason is because there's a linear term. So if there's a linear term and it's not in a parenthesis, there's no way to use the square root method. This one I would use factoring if you think about it. What times to be 28 and subtracts to be 3? Again, what multiplies to be 28 subtracts to be 3. 7 and 4, x and x. It's a different, signs are different. Bigger one gets the sign of the middle. Equals 0. X will be 7, or x will be negative 4. So that's the way I would solve that one. I can't use the square root method on that. But on these that we're going to be doing today, you can, because there will always be just a square. There's no linear term, unless it's in a parenthesis. I'll show you how to do those. And that's the only, and so these are going to be way easier to do using the square root method rather than the factoring method. And I'll show you, you could even use factoring on some of these. And then there's a little trick that's going to happen on some of them also. So let's just work through these. These are just some examples. Now, before you start doing square root method, it's really, 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 really nice to have a list of the perfect squares through 15 squared, or 225. So if you notice, 1 squared is 1, 2 squared is 4. That means 2 times 2 is 4. 3 squared is 9. 3 times 3 is 9. All the way through, make this list or copy this list of all the perfect squares all the way through 15 squared. So this is 15 squared, this is 14 squared, so forth, so on. 14 squared is 196, 13 squared is 169. Those 9s and 6s switch when you do 13 squared compared to 14 squared. 12 squared, I think we've done this list before. 12 squared is 144, so forth, all the way down to 1, which is 1 squared. But having this list is going to make this assignment easier on you. So that would be nice to have. So how do I solve this equation? Now I'm telling you, most kids miss this because they forget to do the plus or minus. So let me just ask you this question. What would x be so that when I square it, it will be 81? You can kind of look off this list here. What would x be so when I squared it, its value would be 81? Most of you are saying, hey, it's 9. 9 is correct. But what if I plugged in a negative 9? Would it still be correct? What's a negative 9 times a negative 9? Oh, that's also 81. And that's why when I take the square root of both sides, which is the goal on these, I want to get the square value or the square part by itself and the constant on the other, and then I'm going to take the square root of both sides. Here's the problem. If you do square root of 81 on your calculator, it's going to tell you it's 9. That's right. But it's also, in this equation, negative 9, plus or minus 9. Now, how come it's plus or minus 9? Again, if you plugged in 9 and squared it, 9 squared is 81. If you plugged in negative 9 and squared it, negative 9 times negative 9 is also 81. So there are two answers to this one, right there. Also, if you think about this in a graph, I'm going to do that down here. If I said, hey, I've got x squared minus 81 equals f of x. So all I did is I took the 81 over to the other side and set this equal to f of x. So if I had this equation, where would I start it? Clear down at negative what? 81. As I came out 9, how high up would I go? 81. So over here at 9, 0, I would cross the x-axis. Now, guess what you would do in a negative direction? Over here at negative 9 and 0, I would do the exact same thing. I'd come out here and cross the x-axis. So really, these 2 points still cross the x-axis. It's still a parabola because it's squared, and it still crosses usually at 2 points unless it bounces off or doesn't cross at all. So in this case, it crosses at the 2 points 9 and negative 9. So both of those are answers. So don't forget, when you take the square root of both sides, you have to take the plus or minus square root of the numeric value. So I did plus or minus square root of 81, which is 9. Okay, let's do this equation then. Solve it the same way. Now this one isn't equal to the perfect square of 81, but can I make it equal to the perfect square? Yeah, just simply do what to both sides to get the square value. Again, this is your goal. Get that square value by itself on one side of the equal sign. So what should I add to both sides to get that square value by itself on the left side of the equal sign? Exactly, you're going to add 9. So therefore I have x squared equals 9. Now what should I do to both sides? What should I do so that that's an x and not an x squared? That's right, take the square root of both sides. Now I'm going to have x equals, what's the square root of 9? Now a lot of you again are going to just say, oh, it's 3. You're not wrong. But because of this equation, because we have an x squared, it's both the positive of 3 or negative 3. Because again, 3 times 3 is 9, but so is negative 3 times negative 3. Negative 3 times negative 3 is also 9. So plus or minus every time you take the square root. So far so good, looking easy, right? There's a problem. This next one's going to be a problem. I'm going to subtract 100 to the other side. This is x squared equals negative 100. I'm going to take the square root of both sides. X equals, what's the square root of negative 100? A lot of you are saying 10. You're wrong. Oh, wait, it's negative 10. You're still wrong. Because what's negative 10 times negative 10? Positive 100. What's 10 times 10? Positive 100. You can't take the square root of a negative value. Try it on your calculator. See what it says. Hit on your calculator, hit square root of negative 100. It either says no real solution, not a real answer, no solution, undefined, or imaginary value, something like that. It really is saying, I don't know how to do that. Because there aren't two things that are exactly the same that times to make negative 100. You'd have to have opposites, and that isn't going to work. So really, this is plus or minus. We'll get into this later, but that's going to become an imaginary number, and we're going to take the square root of 100 being 10. It's going to be plus or minus 10i. But don't worry too much about this I value yet. Just know that you can't take the square root of negative 100 and get a real value. It's only going to be an imaginary value. Now, why is that? Well, let's think about this and why this one isn't working very well. If I think about this as a graph, again, I would have x squared plus 100 equals f of x. Where would this graph start? Where does it cross the y-axis? Notice I gave myself a ton of room up here. Why did I give myself so much room up there? I got to go up what? I got to go up here to 0, 100 to start the graph. And then is it going to open up or down? It's positive x squared. This is going to open up. Is this sucker getting anywhere near this x-axis ever? No, never going to cross the x-axis. So that's why this has no real solutions. There's no place it crosses the x-axis. We did that on the last assignment. You remember that we had ones that would graph entirely above or below the x-axis, and those would have no real solutions. Now they have what we call imaginary solutions, or if we took the reflection of this, it would look like this, and it'd come out here at 10 and over here at negative 10. But that isn't what we're doing. We're not finding the imaginary solutions. We're only finding the real solutions. And there are no real solutions because the graph itself never passes the x-axis. So if you take the square root of a negative, you can stop right there and know that the answer is no real solution. Okay, on these. All right, now don't just assume it's no real solution because there happens to be some negatives in the problem. Let's take a look at this one. It looks like, oh no, we got negatives, it must be no real solution. Don't do that. Solve it out and you'll see sometimes they actually turn into positives as you do the math. So I'm going to add 15 to negative 42. Well, that's still negative. So what's negative 42 plus 15? Well, that's negative 27. Okay, equals negative 3x squared. My goal is to get this x squared by itself. So I want to divide by negative 3. X squared equals 9. Negative 27 divided by negative 3. Now it's positive. Because I had a negative divided by a negative, it became positive. Now I can solve this. I can take the square root of both sides. What will I get? Plus or minus 3. So those are my two answers. My answers on that one are plus or minus 3. Again, the goal was to get the squared value by itself and then solve. Well, this one looks weird because it's not an x squared, it's a squared parenthesis. But the steps are the same. You want to get the parenthesis part by itself and then simply take the square root of both sides. Therefore, I have 3x plus 9. Don't change signs on anything on the side that the x is on. Equals. But I do have two signs over here. I have plus or minus. What's the square root of 36? Square root of 36 is 6. Now, here's where it gets tricky. Right after you do the plus or minus of both sides, you need to set up two equations. Remember, there's 2 points. On this one, there was 9 and negative 9. On this one, there was 3 and negative 3. But these won't be exactly opposite each other. But you will still have two answers. I've got to set up two equations at this point. 3x plus 9 could be the positive value of 6, being the square root of 36. Or 3x plus 9 could be the negative value of 6, being negative 36, being the square root of 36. Remember, negative 6 times negative 6 is positive 36. So therefore, I'd have to solve each of these equations separately, and they won't give you just opposite answers like 3 and negative 3 and 9 and negative 9. This is going to give you two different answers. So I'm going to subtract 9. 3x equals negative 3. Divide by 3, and x will be negative 1. Here I want to subtract 9. And this is where kids make a mistake. They say, okay, that's still negative 3. No, it isn't. Think about a number line. You're at negative 6, and you minus 9 more. You're clear to negative 15 at this point. And then you want to divide by 3, and x will be negative 15 divided by 3 is negative 5. So my answers are negative 1, and negative 5. Those are the 2 points that will cross the x-axis. Negative 1 and negative 5. Okay. Let's do one more of these. Sometimes they don't come out to be perfect squares. I mean, all these that we've done up till now, all these values ended up being perfect squares. There was a 36 there, there was a 9 there, there was a 9 there, there was an 81 there, there was a 100 there. They're all perfect squares. This one doesn't have perfect squares, but it'll still be okay. This one, though, is going to ask you to round your answer to the nearest hundredth, which means you're going to have to punch in the square root into your calculator when you're done. So let's do this one. This is going to be minus 7 from both sides. And then we're going to get 2x squared equals 19 minus 7 is 12. Divide by 2, x squared equals 6. 12 divided by 2 is 6. Now I take the square root of both sides. Here's the problem. What is the square root of 6? It's not on this chart. It's bigger than that, but less than that, so it's 2 point something, probably about 2.3 or so. But we're going to do this on our calculator to find out. It's plus or minus the square root of 6. Now we're going to do that on our calculator. So we're just going to punch in square root of 6 on our calculator. And it says 2.449. Now I want to round that to the nearest hundredth. So this is going to be plus or minus 2 nearest hundredth means 2 decimal places, 4, 5, rounding that 4 up 2. So this is what the calculator said it was. I want to round it 2 decimal places. So I'm going to go 2.4, round that decimal up, 2.45. So 2.45 is the square root of 6. It's plus or minus still. I still have 2 answers. One at positive 2.45 and one at negative 2.45. But those are going to end up being non-perfect squares, and they're going to ask you to round it to the nearest hundredth by doing the square root on your calculator. The last type is a story problem. So we're going to do one basically dropping pumpkins off of the Spartan Center. Or no, maybe they dropped them off. I don't remember where they dropped them off. I think they dropped them off of the auditorium. So let's say we're dropping pumpkins off the top of the auditorium. They know that the top of the auditorium, or where they were dropping the pumpkins off of, was 196 feet. So it was 196 feet up in the air. And we're going to drop pumpkins off the auditorium. Well, what's going to bring the pumpkins down to the ground? Gravity. Well, that's what this negative 16 represents. Gravity is negative 16 feet per second squared. So for every second squared, it's going to drop 16 feet for each second squared. All right, so it's dropping 16 feet per second squared. That's why it's negative 16t squared, time squared, okay? Plus 196, that's our initial height of how high we were dropping them off. So the building was 196 feet tall. And any point in time, I could find the height of that pumpkin as it dropped off the building. Okay. Now, obviously, there's going to be some wind resistance. It might take a little more time, but it's going to be pretty close. Okay. And it doesn't really matter what the mass is as long as you were in a vacuum. But of course, you're not. So the wind resistance of a feather, for example, is a lot different than the wind resistance of a pumpkin. But here, we're going to say that it's as if you were in a vacuum and you had no wind resistance. So here we go. We're going to, and so it'd be the same whether it was a feather or a pumpkin. Here we're going to solve this equation when it hits the ground. Now, what does it mean when it hits the ground? What is the height over time of the pumpkin when it hits the ground? The height is what when it hits the ground? It's 0. So all I need to do is substitute in 0 for f of x. And then solve this. Well, you'll notice there's no linear term. There's only a t squared. The easiest way to solve this one is by the square root method. So I first want to subtract the 196 to both sides. And I have negative 16t squared, that's this side, equals negative 196. A lot of kids freak out right here and they say, oh, I got negatives. Must be no solution. Well, obviously it's a solution. The pumpkin dropped on someone's head almost. So yeah, people are dying by dropping pumpkins. So you got to be careful. And it can happen. You never know. All right, the next step is then to get the t by itself, the t squared part by itself. I'm going to divide by negative 16. Now maybe 196 is divisible by 16, but I'm not going to even mess with that. I know a negative over negative is a positive, 196 over 16. I don't want to reduce it. How come I don't want to reduce it? Well, the next step is going to be to take square roots. And I look over here and I'm like, well, 196 is already a perfect square. And 16 is already a perfect square. I'm not going to reduce this. I'm going to take the square root of both sides right now. So t equals plus or minus, and I'll explain the minus on this one in a minute, square root of 96 over square root of 16. What is the square root of 196? It's 14. So this is going to be 14 square root of 196 over the square root of 16, which is, square root of 16 is, that's 4 squared. So this is going to be over 4. Now I'm going to reduce it, because now I don't care whether they're perfect squares or not. So the time it takes for that pumpkin to hit the ground is 14 divided by 4. Now think about, you can just punch that into your calculator and get a decimal. 14 divided by 4. But you could also just do it by thinking it through. What is 14 fourths? 4 goes into 14 3 times with 2 fourths left over, or a half. So 3.5 seconds is how long it's going to take for that pumpkin to hit the ground. Now, how come I only use the positive on this one instead of both the positive and the negative? Well, for one, you can't go back in time. So you can't go the negative direction of time. So you can't have a negative time. So that's one reason why I'm not using the negative. The other reason I don't use the negative is because really you don't have a negative distance either. You can't go back up on top of the roof. Gravity is always going to push down on it. It's not going to allow that pumpkin to rise back up onto the top of the roof unless you're in a pumpkin patch with Linus, and then the great pumpkin may rise. But that's the only time I can ever think of that you could use negative time. And that has never happened to Linus. He sat in that pumpkin patch for years. So keep that in mind. We probably don't want to use negative time. We're going to use just the positive of time. So usually when we solve a real world example, we only use the positive value. We don't use the negative value. You can think of it also when you use distances. Do you ever use negative distance when you solve an equation? No, you don't use negative distance. You don't use negative time. You don't use negative distance. You only use the positive. All right, so that tells you how to do all the types of problems that are on this problem set. I want you to do problem set 4.3 out of your green book, problems 1 through 26 all. Thanks.